Hello, this is the 2014 Exam 2 Networks question, question 4. So jumping straight to it, we've got 13 activities times in hours. We want the earliest starting time of activity F, so the earliest possible time this could start. So it's either going to take 5 or it's going to take 7. So we take the longest one. This has to start after B is finished, but also after D is finished. D is finished after A is finished, so that means the earliest starting time is going to be 7. The minimum time in which all activities can be completed is 21, so that's the length of my critical path. The LST of activity L, which is going to be from here, we know it must complete at 21, so then L must start no later than 18 if it is not to delay the completion time of the project. So 21 take away 3, 18. The float time of activity J, so the longest route through the graph involving J. We've had a hint that that's the EST that way, so we've got that. And then there's actually only one route through the graph involving J, which is that one there. So A, D, which is 7, plus 4, which is 11, plus 2 is 13, plus 6 is 19. So that route through the graph is 19, the critical path is 21. So J must have a float of 2, because 21 take away 19 is 2. Just before they started restoring it, another activity was added. Activity X takes 7 hours, has no predecessors, and completed before G. So no predecessors means it starts at the start, and completed before G means it meets at that point. So we'll draw out activity X there, and it's going to have a duration of 7, I believe. Yep, 7 hours. Okay, the LST, if it is not to increase the minimum completion time. So it takes 7, and I must be here by... Actually, let's figure that out. So we need to know if this is a critical activity. If G is critical, then we can't delay it. If G is not critical, then we have some floats that we can play with. So we're looking for a route of length 21. So 5 plus 6 is 11, plus 3 is 14, plus 7 is 21. So that is a critical path, meaning that I cannot delay the critical path, which means that the latest time I can start X is 4, because 4 plus 7 would be 11, and this here must be started no later than 11, because 5 plus 6 is also 11. So it has to start at 11 with no delays. So the LST of X is going to be 4. And then this one here, activity A can be crashed by up to 4 hours. It'll reduce the minimum completion time. What is the least cost to give the greatest reduction? So activity A can be crashed. So we have to find the longest route through the graph not involving A. So we've got B, E, H, K is an option. So 5 plus 2 is 7, plus 4 is 11, plus 7 is 18. So B, E, H, K is 18. And then maybe if we go this way, or B, E, I even, but E, I is not as long as F, J. So it's going to be B, F, J, M. 5 plus 4 is 9, plus 2 is 11, plus 6 is 17, so close, but not quite. So the most I could reduce my critical path of 21 down to is 18, because I can't reduce this 18 because only activity A may be reduced. So reducing it down from 21 to 18, I would reduce A by 3 at a cost of 90 per hour, is going to cost me 270. And that's it for that question. So I hope that helps, and I'll see you in the next one.